Okay, this last one is for you masochists out there. This one is a seemingly simple little problem, and what we want to do is sketch this guy's curve. And from pre-calc again, we go there and we go, what do we know from pre-calc? Well, I, one thing I know for sure is that 2 minus x squared has got to be greater than or equal to 0. We're talking domain here, right? So that means, well, a way to do it. That's actually a quadratic inequality. So maybe radical 2 plus x, radical 2 minus x. And if you test the intervals, now we're talking just the function itself. Well, he's called h, so I'll call him h. We have minus radical 2, positive radical 2, or maybe you guys remember the story about like semicircles. What you're going to find is that when you plug in these numbers, h is negative here. Well, you can't square a negative, so get rid of that. Then it's positive, that's okay. Then it's negative again, and no, we're not going to square root negatives again. So the domain is basically from minus radical 2 to radical 2. That's it. So the action, when we start to graph this thing, maybe we're starting to do it over here, everything is happening between minus radical 2 and positive radical 2. Thank you, pre-calculus. That you've been a big help. So the rest of this is, I guess we're just going to have to go after this and find domains and do our usual thing here. So there's h. It's got an x and a radical 2 minus x squared. There's some tricks here that are good for you to see. So h prime of x, product rule, right, would be x is 1 times the square root of 2 minus x squared, and then plus x times the derivative of this guy, which is memorized to be 1 over 2 radical 2 minus x squared. All kinds of traps and snares to watch out for. But you got to hit them with the derivative, which is negative 2x. Thankfully, I've got a little bit of a cancellation with the 2's, but that's about it. So your h prime of x is looking like a radical 2 minus x squared, and then we have a negative. The x's meet on top, x squared, all over this radical again. Now, typically, what we're doing next is, gee, where's that equal to 0? And where's it not defined and all that stuff? Well, it's hard to figure out. Well, there's different ways to figure out where it is not defined or where it's 0. One way is to actually solve this equation and come up with some sort of answer, and it's totally doable. But I grew up for some reason in doing it this way. Namely, I put this guy over 1, and I reach a common denominator. It is going to be helpful in two ways. It may not want to do it, but I'm going to do it, because once it's together as one fraction, then maybe I can do the quotient rule for the second derivative, and it's easier. But also you see this thing happening. So h prime of x, these two meet and cancel out the radical. Now downstairs is this radical 2 minus x squared. He hasn't changed, but now we have 2 minus x squared freed of the radical minus x squared. And so life is perhaps a little easier in this regard before I go after the sign. Like I said, not for the faint of heart, but it is a calculus problem. And now we're going to play the game of where's that equal to 0? Well, you can go farther with the numerator. You can say the numerator is like take out a 2, difference of squares, 1 plus x, 1 minus x. And downstairs is this guy. And you start feeling a little bit of the nice stuff about calculus. You've got this going on. All right, so that's the first derivative. What we know downstairs is that it's undefined. Let's call it h prime does not exist at x equals, well, beyond it too, but plus minus radical 2. But also from upstairs, h prime equals 0 at x equals plus or minus 1. Okay, that's helpful. So what we do next is, as usual, we take a look at this guy's, the sign of the derivative, which in our case, I'll write it as 2, 1 plus x, 1 minus x, all over this radical. Okay, 2 minus x squared. So We know we have to stop at minus radical 2. Don't go beyond that. It's not defined, and we know we stop at radical 2. In between there, though, guess what? We've got a minus 1 and a 1, interestingly enough. Not to scale, but there it is. And we are going to test the sign of the derivative there. So that means we're going to plug in numbers like, I don't know, say x is equal to, did you know that this is like a negative 1.4 or something like that? So how about negative 1.1 here? How about x is 0, and then x over here is positive 1.1 maybe, okay? And I'm not going over here because the function doesn't exist on that side, okay? It's not defined. You plug in the numbers. Now here we go. Downstairs is a square root. Guess what? It's always positive. Just like squares, the square root, the principal root, is defined to be positive. But upstairs, when you plug in, say, a negative 1.1, we get a 2 is positive, we get a negative and a positive. So we get in a negative and a positive. The net result is negative, and so it is decreasing, right? It's decreasing there. When x is 0, you got upstairs, you got a positive. Positive, positive is definitely positive, and it's increasing. Then finally over here with 1.1, it's positive, but when 1 minus 1.1, you get a negative. So it's a positive negative. The result is negative, and down she goes. Okay, so the same story. We're going to state what we have so far, and that is looking like right here is a min by the first derivative test, and here's a max. So let's take a pause and write out what we found so far. Okay, so f is decreasing on 2 places. Minus radical 2, 2 minus 1, but also from 1 to radical 2. F is increasing on, and it's only doing that on minus 1 to 1. Okay, and then we can say f has a min of f of, and what is it? Negative 1, and you got to go up to the original function here. Where are you? Where are you? Where are you? Way up here, and plug a negative 1 into that. So it's negative 1. Let's see, where are you? It's equal to negative 1 radical 2 minus negative 1 squared. The net result is negative 1. F has a max of f of 1 equals 1 square root 2 minus 1 squared is 1. Wow, okay. I have a feeling we can graph this thing maybe a little. So we'll get out our graphing marker and we will start it. One thing I didn't notice or didn't say is we didn't do the x or y intercept here. So maybe we should. If you look at this function really easily, h of 0 turns out to be 0 because of him, right? Okay, so we know we go through there, right? And we know we have a min of minus 1 here maybe, and minus 1. Then we have a max of 1 and 1. Oh, and also, what else can you find out about this? Look at underneath the radical. If you plug in plus or minus radical 2, you also have it. So let's put a table here. We've got the intercepts. We've got x and h of x going on like this. 0, 0, plus minus radical 2, also 0. So they go through these points. Had to find that out. And this point. So you get this, okay, I think it's doing something lovely, like, well, something like that. I think, okay. Pretty good graph. What about concavity? Oh, I bet it's concave up and down and we're done, right? Who said concavity? Do you mean we have to do that one too? If you do that one, if you're told to do that, maybe Weber will be nice. But if you are told, then you have to go for h double prime of x, of course. Now, what is, okay, right here is h prime. I'm going to use that and derive with that. So downstairs, I square it. You know what I square a square root? I get 2 minus x squared. But up comes the square root, 2 minus x squared, and times the derivative of the top, which is minus 4x, and then minus the top, which is 2 minus 2x squared. Derivative of the bottom, man, is, we've done that one already. It's 1 over 2 radical 2 minus x squared. Derivative is a negative 2x. I had to squeeze it in there. All of that upstairs. It's not fun. So, yeah, that's a mess. What can we do here? What else can we do? If you're still with me, fantastic. You're tough. I'm going to cancel those 2's maybe. I'm not really looking to factor out anything. I don't think I can. But one thing I think could be done is to multiply top and bottom by 2 minus x squared. These are some of the tricks that I've learned as a student, as a teacher. What happens is I'm clearing this denominator and wreaking havoc on the rest of the problem. So follow me as I do this. He's going to come all the way screaming over here and hitting the numerator. And that releases the 2 minus x squared here. You still have a minus 4x. You still have the minus. You still have the 2 minus 2x squared. And then he reaches in here. You have another x. Oh, and you have a double negative. So this guy is plus, isn't he? A double negative and an x. How's that looking? Okay. You know I'm looking at this carefully. And then we have 2 minus x squared to the 3/2 power. We're still working on this thing, trying to make it friendly to us. The numerator turns out to be, let's distribute, maybe minus 8x, is that right? Minus 8x, and then we have plus 4x cubed. Oh, that's right, that's right. One thing else we can do, let's factor out the x. Let's factor out this x right here. Get him out of the way. I think that's all I'm going to do. Take out the x, and if you take out the x, now what you've got is 2 minus x squared times the minus 4. It's a labor of love, I'm telling you. Plus, the x is gone, and I'll just say 2 minus 2x squared. And downstairs is still this 2 minus x squared to the 3/2 power. Okay, it better be worth it. So we're getting h double prime is equal to an x. Downstairs is this thing, 2 minus x squared. And then to the 3/2 power. And what else? We've got a minus 8, right? And then we have a plus 4x squared. And then we have plus 2 and minus that. So plus 2 and minus 2x squared. Boy, howdy. You can tell. I can tell I'm getting tired. I get x. And we've got 2x squared. And we have a minus 6, it looks like, minus 6. And then downstairs is this thing. If I did that right. Okay, I think so. Every time I do it, I get something else, something different. If this is wrong, don't worry. I'll just delete the video. No one will be the wiser. So I'm finding downstairs the usual x shouldn't be plus or minus radical 2. But upstairs I'm finding 0, x is equal to, but also interestingly enough, plus minus the square root of 3 over 2. Okay, whatever that turns out to be. So searching for concavity, this is getting kind of lengthy. You can see how tough this is. I wonder if I did that right. I got to be careful. Let me check my derivative up here. So I got deriving that guy. He comes up and you derive that. It's a negative 4 radical minus 4x. And then he multiplies with that derivative. I think we're doing okay here. The double negative occurs and you got a plus and a minus. So I think we're okay. And then you gather stuff up. You took the x out, you got that guy with a minus 4. It's nice to write all this stuff out. Okay, all right. So the number line then, the game would be, remember, negative radical 2, no. Positive radical 2, no. But we're going to mark off this guy. What is the square root of 1.5? Anyone know that? I think I might know, so I'm going to do it anyway with the calculator. 1.5 is I didn't know, it's 1.2 roughly. So we're also finding, well, there's a possible inflection point here, there's one here, there's one here. That's a negative radical 3 over 2, and that's a positive radical 3 over 2. I'm going to rush to the finish here. I think what happens, because this is getting kind of lengthy, but what you would do is you'd plug in a number like 1.3 here or something bigger. So what we're finding, I'll be kind of quick here, the sign here is positive because it's a square root. It's actually a 3/2, but it's a root, and yeah, it can only be positive. So that one's okay. But downstairs, that x is negative, negative, and then it's positive, positive, because you're positive numbers. And you plug in this guy, he's bigger, he's going to be positive, but then smaller, he's negative, and then smaller still, he's negative, and then positive. So the net result is negative, concave down, and then positive, concave up, and negative, concave down, and positive, concave up. What a bizarre thing. So you got to write all this stuff out. F is concave up on, F is concave down on. Do we have any inflection points? Yeah, we do. We've got F has inflection points at, there's a down, up, down, up. Yeah, there's 3 places at x is equal to plus minus radical 3/2 and also 0. Okay, I'm going to cut to the chase, go back up to our graph and inspect it. I thought it was just going to be concave up and concave down. Well, it is concave up in the middle. It's concave up and then it's down, but it has this little concave down at the edges here. How is it concave down here and then concave up here? It's interesting. Take a look at Desmos. You may be able to see it. It gets kind of steep at the edge there, so there might be a slight concavity at the edges. I did not expect that. Well, that's how hard it can be, and that's a pretty crazy problem. And that's it for this particular recording. I hope you enjoyed it. It's like I said, for those of us that like a challenge.